So I can't do anything without adding like a little bit of engineering flair to it. By the way, my name is Mathis. I'm engineering lead at This.Labs. We're a consulting agency that specializes in JavaScript development for web and mobile applications across a variety of industries. And what my Ignite talk is going to be about today is kind of just a bit of, thinking around like evolution versus revolution when it comes to coding with AI. Are we in a revolutionary time, or are we in another evolution of technology? So, to talk about the history of computing really is a lot, I think. So I'm going to go very quickly here, and I'm going to set myself a stopwatch, and I'm going to be done in about 7 minutes. 1980s, the United States had a major issue when it came to tabulating the census. It took 2 years to count up the totals. Too much counting took too long. They asked a guy by the name of Herman Hollerith to create a machine that can make this faster, and he created what was called the Hollerith tabulator, which used these punch cards. Oh, are we falling off? Check 1, 2, AV.
Your other picture was up.
Mm-hmm. Uh-oh. I'm seeing black right now. Did I step on a cord, maybe?
HDMI.
Oh.
It's this right here.
Do not touch that cord right there. Now everything's black. Oh, fantastic. Okay. By the way, if you want to follow along at any time, just scan the QR code at the top of these slides. This is running on a Next.js website hosted on Vercel, so you can kind of stop on an image that you want. But to go back to what we were talking about tabulator computers. These things use punch cards punched by real humans to record and store data and display it and calculate and summarize it for the United States Census, and it solved a critical problem. It took 10 years to complete a census. With this machine, it took just 6 months. Someone was like, oh my God, I should sell this to insurance companies. So this was kind of like the first computer ever created, and you would program this thing via like a plug board, which is an absolutely crazy concept. You would load data in via punch cards, and this thing was completely electromechanical. You had to be a specialized individual to be able to dive into this thing and diagnose issues that were going wrong. Well, kind of happening at the same time as these things called vacuum tubes are getting created, and the information era was sort of being born. And information theory was this concept of storing data as ones and zeros. And a woman by the name of Grace Hopper said, you know what? Let's put the code inside of the computer. So, a few people were like, okay, that's interesting, but let's kind of get started with a few of these major devices. So we have the ENIAC computer gets created in 1946. In the early 1940s, 6 key women are selected from the mathematics department at the University of Pennsylvania to do some of the first programming ever. They created concepts like breakpoints. They created concepts like debugging and some of the fundamentals that we use here today. And this computer eventually evolves into the IBM 604 patch panel computer. You program this by like wires, y'all. Could you imagine writing code like this, loading it into a machine? This is crazy to think about. This is what a programmer looked like in 1995, all right? This is your company repo. This is where you kept all of your code, all right? Each one of those are patchboard panels. You load them into the machine. There's DevOps working late at night, deploying your code into the machine. Come on, look at this. Diagnosing. For real? Come on. How am I going to find an error in this? This was documentation. What? Come on. I can't it's too much. It's very complicated. And, Grace Hopper, she's like, for real. Let's put the code inside the computer. And we had one of the first major revolutions, in my opinion, in computer programming, which is the ability to modify code directly inside of a computer. You could do this on the UNIVAC, released late in the 1950s. It still used vacuum tubes. It used a very interesting system for storing memory. It used what was called a UNIVAC Mercury delay line memory system. This was a giant transistor surrounded by 8 glass mercury-filled tubes, and it would store information by sending sound waves through these mercury tubes, and it would bounce back and forth on the tube. And eventually someone said that mercury stuff is kind of crazy, y'all. Let's not do that. They created the IBM 704. And things kind of mostly stay the same with the 704. Languages like Lisp, Fortran, Algol 20 really rise in popularity. We're kind of still in the 50s here, 1955. This was a common IDE environment for you. all right? 1950s, punch cards still very prevalent. You did never want to drop these things. You dropped them on the ground and they became disorganized, you had a disaster. People would actually strike them diagonally with lines in case they did drop them on the ground. Maybe you could reorder them again by looking at the diagonal line on the side. Best of luck to you, right? Here's some programmers in an open office, 1950s. Pair programming, late 1950s, you would write code and then you would verify it on another machine. You had to have two people doing this stuff. This stayed pretty constant all the way up to 1957. IBM comes out with the 709, which is a totally vacuum tube powered computer. But then transistors come onto the market. And we have the IBM 7090, 1959. Coming into the 60s, what does the 60s remind everybody of, right? The space race, okay? NASA had a mandate from the president to send a man to the moon, and we had to go bigger, we had to go faster, we had to calculate things at rapid pace. And we went from the Redstone 3 rocket, which sent the first man into orbit around the Earth, all the way up to the Saturn V. Size comparison for those of y'all that need to understand what a monumental engineering lift this was. We needed computers that could go really fast, and that's where the IBM System 360 comes into play, 1964. This computing system was used pretty pervasively through NASA, introduced the first ever unified architecture where you could upgrade things piece by piece. You know, beforehand, if you wrote code for a machine, it only ran on that machine, period. If you got a new one for the next year, you had to rewrite all your software. That was a disaster for business owners. The IBM 1130 console, this was sort of like an interactive development environment now. You actually, for the first time, got feedback from the computer. You weren't running things in batch. You could send an instruction, and you could get information back. 1965, this happened. That was like revolutionary at the time. Everything was done batch. You had to wait overnight for your code to run. This is kind of what an office environment looked like 1965, y'all. A similar computer here, the PDP-7, this is what Unix was developed on. That is what it was coded on. That is a teletype machine. That's a console that is completely, that PDP mainframe, but that console, it prints out paper. Paper. It's like you opened up your JavaScript console in your browser and imagine your printer started running. Oh my God. I need to see the output now. Why is it taking so long? Everything's electromechanical. All right. This is what Unix and the C programming language were essentially built on. Dennis Ritchie and the group, and along with a few other critical languages. COBOL, checking my time here, we're looking good. BASIC, a couple examples of BASIC. Lisp at the same time, 1960s, Lisp is coming out. Lisp-oriented style syntax that was really revolutionary for the time because it was used to create the first ever AI chatbot called Eliza. This was like breakthrough, y'all. 1964, we're doing the first ever AI chatbot. We've been working on this AI stuff for a while. Again, this is what we're using, right? We really needed a revolution bad. We were printing out punch paper tape. You'd maybe tape it together and run it through the machine again too. You would call that a loop. You tape one in together, literally run through the machine multiple times so the code could rerun. But the big revolution sort of breaks place here with microprocessors, and this is where I'm going to go really quick, because when the 8008 processor came out, the semiconductor manufacturing industry kicked into high gear, and we could finally make these wafers in the 1970s. You did this by hand. You carried them through the manufacturing plant by hand. You operated the lithography device by hand, but we created some crazy computers. This was just a typewriter, 1973. It didn't do anything. You could just type on your screen. The Altair, some of y'all may be familiar with this. Someone was like, yeah, that's a cool computer, but the way you coded it was you flipped these switches, and you wrote everything line by line by flipping switches like this. Someone said, nah, we need a revolution, all right? And they plugged it up to a TV and a keyboard, and stuff really kicks into high gear from there. Lots of computers explode outwards. Sorry, that might have been a bit too fast. But I mean, this was like, the TRS-80 was like the peak in 1977. The Apple II, 1978. The Apple II with a monitor. And just 15 years ago, that was the peak of computing at the time. All right. Continue to go forward. 1980s, we have the Commodore, Apple Lisa, Macintosh comes flying out. 12 years ago before that, when the Lisa and the Amiga came out in 1987, that was only 12 years ago. Continuing forward with lightning pace modems. This is how we used to connect to the internet. What the heck? All right, you put it on that? What? Seriously? Whoa. Major revolution happens. We're able to plug modems into computers, and we birth forth kind of like the beginnings of the internet. BBS systems where you could share code, share games, communicate with other people. We used to send code to people printed off like that, and that's you programmed it in by typing it by hand. Now I could send you a floppy disk. We had evolutions in GUIs. This was a GUI from 1983. Then check out Windows 1. Amiga Workbench in 1984. This is all the 80s. This happened in a decade. We went all the way to that. From like that. That's crazy to me. The 90s, I'm kind of getting more into the territory of stuff it is that y'all are familiar with, like, you know, the early release of Linux, Python coming out, Windows 3.2. This was my home computer in the beautiful hot dog theme that you could apply to Windows 3.1. I loved that one. The Amiga 1200 was very popular. Windows NT released 1993. The Mosaic Internet Browser, 93 and 94 come out. And Java in 1995. And 1995 kicked things into high gear. All of these languages came out. Windows 95 came out in 1995. Did y'all know that? That's crazy, right? This dude sold us an operating system 1995, 20 years ago. He saw that, right? 20 years. You know, continuing on into 1996 and into the early 2000s, I always kind of like to stop on this slide. 1998, Google looked like this, all right? Salesforce looked like this, 1999, salesforce.com. What? First SaaS application. Bunch of new languages start to burst forth in the early 2000s. The Agile Manifesto is founded 2001. Multi-core processors created 2001. Windows XP releases in 2001, and a bunch of languages burst forth on XP. That doesn't look right. Yeah, that looks a lot better. Yeah, that's nice. Ubuntu Breezy Badger. This was like my daily driver operating system, 2005. Amazon AWS, 2006. The NVIDIA CUDA, you could actually write compute level instructions to a GPU, and you didn't have to use like obscure vertex shader oriented programming libraries to do compute on a GPU. Major smartphone evolution flies through. Maybe not that much of an evolution, but that was an evolution. That was a major deal. And then Stack Overflow, 2008, GitHub 2008, Node.js, Go. This guy was trying to sell us an operating system 14 years prior to when Node.js came out. It's Windows 95. Now, kind of launching forward, we're in the current era. Y'all remember the browser wars of 2013? I do. Or the JS wars, sorry. The browser wars was before that time. Rust and Swift released 2015. TensorFlow and PyTorch now, like, you know, PhD people, master's level people, anyone could build a machine learning system. AlphaGo gets released. We finally have quantum computers explode forth in 2019, and now that kind of brings us to today, 2022. We're coding with AI. And I want to ask you now, do you think we're in an evolution right now or a revolution? Because in 2026, that would have been 80 years ago. Programming computers, punching them in with plug boards. You know, put some thought towards that. That's my talk, y'all. This entire slide deck was built in Next.js with AI. I used Anthropic. You can scan the QR code at the top to view the GitHub repo. I spent $44 in prompting to write this entire website. I didn't write a single line of code myself. Do not even ask me about the carbon emissions that might have been generated from doing this, because it's like the equivalent of driving a car like 34 miles or something like that. But we're getting better, but I figured just a little openness would be nice here. But that's why I like taught y'all. Thanks.